Continue curve sketching. Now let's look this one. Y equal to x sine x. Well, we know that this function is an even function. So therefore, we just need to sketch the half of it. X is positive, right? We sketch half of it, and then the other half, we just use a mirror image. We can derive the whole picture in a domain. Now we know that this function, sine function is an oscillating function, right? The function, the curve is oscillating between 1 and a negative 1. Now we have this function x times sine x. Therefore, x here, it becomes a multiplier, which means that x, this is y equal to x, and y equal to negative x. Then the function, sine function, is oscillating between these two curves. That is the idea in my mind before we sketching it. We just need to grasp the critical points there, okay? When x equals 0 is 0, right? When x equal to half x, this is half of x, then sine x equal to 1, therefore multiplied by half x is half x. That is, this is the point, the curve passing through. When x equals to pi, then sine pi is 0. So the curve must pass in this point. Now then next point is 3 pi over 2, at which sine is a negative 1. So negative 1 times 3 pi over 2 becomes negative 3 pi over 2. And then next point, when x equal to 0, when x is equal to 2 pi, then sine function is 0 again. So this is a point passing through. And then this is 5 pi over 2, then sine is equal to 1. The sine equal to 1 times 5 pi over 2 becomes 5 over 2, okay? Then, and so on. So we can sketch the curve more or less like this. Passing through 0 and reach the maximum and the 0 and maximum. Yeah, then here again. And you see, that is a general idea for sketching this curve, and then the picture is symmetrical with respect to y-axis. So this is this is a kind of oscillating the other side. Okay. Now, how about the gradient at the maximum or minimum point? Let's see, the derivative of y equal to sine x times x cosine x. Okay, now let's look at this one. When x equals half pi, the derivative at x equals half pi is equal to 1. It's not equal to 0. Well, do you find that interesting? We are thinking that the function at maximum point, the slope of tangent line to that point should be 0, right? But here it's not 0. See, this is the derivative of y with respect to x. But when x equals half pi, this should be maximum. But the derivative at that point is not a 0, it's a 1, which means that at this point, the slope of a tangent line to that maximum point is 1. Now we can explain this way, okay? This is slope of the tangent to that maximum point, say this maximum point, and here at this point the slope of tangent is equal to 1. So we are, look, at this point the slope of tangent is not 0, is 1. Let me emphasize that. Okay, this is the maximum point. At this point, the slope of tangent is 1. Not this slope is not 0. At the same time that for this point, at 3 pi over 2, at this point, the slope, the derivative at this point is a -1. So the curve looks like this. This is a -1. This is, y equal to x, right? This is at this point the slope of the tangent line is -1. It's -1, not 0. Okay, now you can take for second derivative. Second derivative is equal to cosine, 2 cosine minus x sine x. Well, then after this, when this is 0, we're supposed to have a point inflection. So somewhere, now we solve this equation, let this be 0, we solve this equation for x, then we get those points. These points are point inflection. And somewhere there, it's not an easy equation, but we can imagine that there are point inflection by solving this equation for x. We can get point inflections. So anyhow, this is the curve for this function. Now let's take a look at the picture from internet. Okay, to continue this function. Y is equal to x cosine x. We just analyze a similar way. This function is odd function. Therefore, we just need to draw the half of it the curve, and the other half using symmetry. The curve is symmetrical with respect to origin. We just rotate the curve 180 degrees. You get the other half graph. Now, for this particular function, we just grasp some main point. Now, when x equals to 0, is 0, right? Yeah. When x equals to 0 is 0. When x is to half pi, then it's also 0. Yeah, it's also 0. When x is half pi is 0, and when x equals to pi, then y equal to -1, right? So -1 times pi is -pi. Then next point, this is 3 pi over 2. At 3 pi over 2, cosine is 0. So this is a point passing through. Next one is 2 pi. So at 2 pi, cosine is equal to 1. So y is equal to 2 pi. And 0 again. So this curve looks like this, right? This is -1 and 0 and 1, 0 again. See, this is a curve which is oscillating between x1 and x equal y equal to -x. Now y equal to x and -x. Now here, how do we sketch the? See, we know that point is passing through, right? Then it reaches somewhere, then comes down again. Now, how to find that point? How do we find that point? This point, we're just solving the equation, say y derivative is equal to cosine x minus x sine x. We solve this equation, we get this point. This point is between 0 and half pi, reaches the maximum, okay, and so on. Then the function is symmetrical with this part through by the with respect to the origin. Now let's take a look at the picture from internet. Now also we know that this function at say 2 pi, y derivative at x equal to 2 pi, and we know that cosine 2 pi is 1, right? Sine 2 pi is 0. Therefore, at this point, the slope of a tangent to that point is 1. It's not a 0. The same kind of reason, okay? This is the curve. This is the curve. This is a gradient, and this is slope at this maximum point. Slope is 1. It's not 0. It's not 0. And this is slope. This is slope is 1. This is a 2 pi, and at which that the tangent line to that point is not a 0, but rather 1. Okay. Okay, now let's look another tool. Look this one. Look at this function. Well, we know that this function is an even function, so we just need to draw half of it for x is positive. Then the other half we can use the mirror image to have it. Now we just drop the key points. When x equals 0, the function is not defined. But take a limit when x is approached to 0 from right, and this is equal to 1. This is equal to 1. The limit exists, the function does not. Now, when x is equal to half pi, then x equals to half pi, then this is 1, right? So 1 over half pi is pi over 2. So this is pi over 2. This point is pi over 2. No, I'm sorry. It's a reciprocal, right? Should be 2 over pi. This is 2 over pi for x equal to pi over 2, because this is a reciprocal. That point is a maximum. That point is a maximum. Then for next pi, this is 0, right? This is pi. And then 3 pi over 2 is a negative 1. Negative 1 divided by this one, so this point is 2 over 3 pi negative. Okay, do you see that? Yeah. So this is the point. And so on. Next one is 0. Pi, this is pi. Then next one. You see, that means the curve is oscillating. It's like this. Yeah. It's oscillating between these two curves, 1 of x and the negative 1 of x. The other half, it goes like this. The mirror image for that. Well, I cannot draw nicely because it's not easy. Now let's take a look at the picture from the internet. Okay, now same reasoning, right? The derivative of this one is equal to x squared and x cosine x minus sine x. Well, at this point, when x is equal to half pi, this is 0, right? This is negative 1. So this one is equal to at x equal to half pi. This will be negative 1 over, this is square, right? So it's negative 2 over pi square. That is the slope of the tangent to the point at half pi. Yes. So obviously that the grade, the slope is a negative. You see, the slope is a negative. I'm sorry, no, this I can only show the idea. That is the slope of a tangent line to the curve at this point is negative. Negative 4 over pi square is not to 0. It's not 0. And similar to this point, see, we put this value into this y derivative, first derivative, we get gradient is not 0. Okay, let's take a look at the picture from the internet. Now let's take a look at the next function, y equal to cosine over x. For this function, similarly we draw that 1 over x form. You see the graph is this. This is the curve 1 over x. The cosine function is oscillating between these two curves, something like this. When x is approaching to 0, is infinity. Is infinity. So there's asymptote here. When next point at x equal to half pi, this is 0, right? So passing through this point. For x equals to pi, this is negative 1. Negative 1 over over pi is a so this is this point is a negative 1 over pi. The reciprocal, right? And at next point is 0. And next point is here. The next point is 0 again. Next point here. See, the curve is, yeah, something like this. I can only I can only say about the idea, but she. And for the other half, yes, symmetric with respect to origin. So it goes like this, right? Yeah. Okay, that would be cosine curve. Okay. Now, same idea that the maximum minimum point, the gradient is not, the slope of tangent is not 0. Now let's take a look at the picture from the internet. Okay, all right, that's it. That's enough for today's curve sketching. While we have more examples of curve sketching to come. Thank you for your watching.